Okay, everybody, we're on to our next lesson. We're up to number 4, average rate of change. Should be pretty easy for you guys. So first thing I want you to do is explain how you know what each table is representing, what type of function. So just to be clear, like, what are some types of functions? Linear, quadratic, exponential, different types of functions. So when you take a look at your first table, g of x, if you notice your x values are increasing by 1, 2, 3, 4. And if you notice your g values, how are they increasing? Like from 13 to 16, 16 to 19, 19 to 22. They're all increasing by 3. Okay? So that has what we call a constant rate of change. Okay? And that is known as a linear function. Okay? So where you take a look at your next one, and if you would say, okay, is this increasing by the same amount? Well, from 24 to 48, it went up by 24. But then from 48 to 96, it didn't go up by 24. If you notice, this is actually being multiplied by 2. 48 times 2 is 96. 96 times 2 is 192. This is what we call a constant ratio, which means it is not increasing, meaning adding or subtracting. It's not increasing by a constant rate. Okay? Which means it's exponential. Okay? Exponential functions are going to be being multiplied by a constant ratio. So today we're going to be talking about average rate of change. So take a look at this first example. Okay, we're talking about a mouse population. And they're saying a mouse population starts with 2,000 mice. Okay, so really important information. Starting with 2,000 mice, and it's growing at a rate of 5% per year. So you could see that right in the equation that they give you. P of t equals 2,000 times 1.05 to the t. So you know it's starting at 2,000, that's your initial, and then it's 1 plus, this is your growth rate, 1 plus 0.05, because 5%, right, 5% as a decimal is 0.05, okay, and they want to know what is the average rate of change in the number of mice between, now they have to tell you what they want, between the second year and the 5th year. Okay, to the nearest whole number. So what I'm thinking is immediately, okay, we need a table. We have, instead of an x and a y, we have a t and a p of t. But there's only 2 numbers that we care about. We want to know between the 2nd year and the 5th year. So we're going to figure out these 2 values. The easiest way to do that is to go into your calculator. Okay, so I'm going to pull up. I don't see it here. I'm going to go here. I'm going to clear all of this. And I'm going to go back here. And I'm going to show you. You're going to go right into your calculator. You're going to type the function, not p of t, just your 2,000, parenthesis, 1.05. Go out of it and raise it to the x. You can't use t, you're just going to go x. Okay. And what you really care about is your table of values. You only need to go from 2 to 5. Those are the numbers you care about. You don't even care about 4. At 2, it's 2205. And at 5, I'm going to kind of round that. It's 2,550. I'm going to say 3. 2,553. Okay, so in order to find, so now here's the deal. Kids will say, oh, between them, oh, should I just subtract them? But here's what you need to do. To find your average rate of change, okay? It's your difference of your y over your difference of your x. So I don't know if you remember this, but that's the slope formula. So what's happening if I use a new color? How is the y? What is the change in y? Take 2553 and subtract 2205. The change in y is 2553 minus 2205, which is 348. And here, the change in x is 5 minus 2, which is 3. So again, you could show that here. You could say, okay, 2553 minus 2205 over 5 minus 2. And that would be 348 over 3, which when you divide is 116. So all you really need to know is that the average rate of change is the slope between 2 points. So I don't know how many of you remember, but change of y over change of x, we used to write like this, y2 minus y1 over x2 minus x1. That's all you're going to be using. And when they do x2 and y2, just understand, if you pick the second y value first, you just got to pick the second x value first. So I'll go through a few with you guys. So look at this example in number 2. They give you 3 different functions, g of x, h of x, m of x. They want you to find which one has the largest and which one has the smallest average rate of change, and they give you a specific interval. You always need to check the interval from when x is -2 to when x is 4. Okay, so let me explain this. Let's look at the table g of x first. The good news is, in the table, they give you all the information you need. You only need 2 points. The only 2 points you care about is when x is -2 and when x is +4. Meaning everything else, who cares? Who cares? Who cares? Okay? So if I come off to the side over here maybe and do g of x's average rate of change, okay? Again, remember, it's the change in y over the change in x. So you got to start with the y values. You could either do 0 minus -8. I'm going to do -8 minus 0. But being that I picked this one first, I have to go with that x value first. 4 minus -2. Now, here's what a lot of kids will also mess up. Be careful. This is difference. Difference means subtraction. Notice up here, it's subtraction. Subtraction. So important. So when you see a negative, make sure you have to do minus a negative. It becomes double signs. So this becomes -8 over +6, which means g of x has a average rate of change of -4 over 3. Okay, -4/3. Okay, I'm going to do h of x now. So I'm going to go new color. I'm going to say blue. And h of x is probably the hardest because h of x just gives you a equation. You now have to go and get a table. So I am going to pull up GeoGebra. I'm going to clear out what I had, and I'm going to type in this function, which is absolute value bars. 2x plus 3. And then outside of it, tab out, plus 7. Okay, so that's what it looks like. I really care about the table, and I only care about 2 numbers, from -2 all the way to +4. So I'm going to write down my value at -2, it's 8, and at +4, it's 18. So at -2 and +4, it was 8 and 18. Okay, so I'm going to come down here and do my h of x. Okay, and again, I'm going to do the change in the y value over the change in the x. So I'm going to always start with my y values first. I'm going to say 18 minus 8. If I pick 18 first, I got to pick 4 minus, be careful, -2. So that becomes 10 over 6. And that it can simplify to 5/3. Okay. So obviously 5/3 is bigger than -4/3. Okay. Going to my last one. These are new color. Purple. Okay, so let's talk about in a graph. So in m of x, okay, if I set up a little table, I need at -2 and +4 again. So go to where my graph is at -2. What's the y value? Here's where it exists at -2. It looks like down at -12. And then if I go to +4, which is over here, it exists at 0. So for m of x, let me do my change in y over my change in x. I would say 0 minus -12 over 4 minus -2. And when I add these together, I get 12 over, add these together, I get 6, which gives me a average rate of change for m of x at +2. So here, right here, no doubt, is your largest. Okay? Okay, so now which one is smaller? So we have to find m of x is the largest, which knocks out these two. Okay, so which one is the smallest? Definitely g of x. Right here, my pink is going to be your smallest. -4/3, and that's your answer. So that was a lot of work, but that's it. It's pretty easy. So I think I'm going to leave you with these last 3 to do on your own, okay? I'll post an answer key, but go get them. Do your average rate of change for those last 3. Okay, have a good day. Have a good weekend.